want to find the limit as x approaches 0 of 1 over x raised to the sine of x. So the way I'm going to do this is by rewriting it as e to the ln of 1 over x to the sine of x. And I'm going to have the limit as x approaches 0 in front. So the sine of x is going to come in front of the limit, and sorry, in front of the ln. So it's sine of x times ln of 1 over x. And I'm going to rewrite this. So let's see, ln of 1 over x can be rewritten as ln of x to the negative 1. And we know that the exponent is going to come out in front, so it's just going to be negative ln of x. So we can write that. And then sine of x, well, we know that cosecant x is 1 over sine x. So 1 over cosecant x will be sine of x. So we're just going to put cosecant x in the denominator. Okay. And then as x approaches 0, we know that from the right, ln goes to negative infinity. And cosecant x, well, that's 1 over sine 0. That's 1 over 0. So that goes to infinity. Okay, so we can use L'Hopital's rule because we get basically infinity over infinity. Okay, so we're going to take the derivative of the top and the derivative of the bottom. So the derivative of negative ln of x is negative 1 over x. The derivative of cosecant is cosecant cotangent. And then that will be negative. So the negatives are going to cancel. And now we're just going to rewrite this. So we know that cosecant cotangent can be rewritten as 1 over sine times cosine over sine. And then we have 1 over x. So basically we're going to have this. Okay, so 1 over x divided by that. And this sign is going to come all the way up top here. So I'm going to get sine of x over x. And I can bring this sign up here, so that would just be sine over cosine, which is really just tangent. So I can change that to tangent. Just to make it easier. Okay, and then I'm just going to rewrite this limit as sine x over x times tangent x. I can break this up into two different limits, so I'm just using the product rule for limits, so I can have limit as x approaches 0 of sine of x over x times limit as x approaches 0 of tangent of x. We know that this limit is going to be 1. And if I plug in 0 in for x, tangent of 0 is just 0. So this is 0. So that would be the same thing as e to the 1 times 0, which is e to the 0, and my limit is just 1. Okay, let's look at another example. So I'm given that f is differentiable, f of 1 is 3, f prime of 1 is 6. I want to find the limit as x approaches 0 of f of 1 plus x over f of 1, all raised to the 1 over x power. So the first step is to rewrite this as e to the limit as x approaches 0 of ln of f of 1 plus x over f of 1 all raised to the 1 over x power. So the natural log is going to bring this exponent out in front here. So we're going to have e to the limit x approaches 0, 1 over x times the natural log of f of 1 plus x over f of 1. And here we can plug in x equals 0. So if we were to do that, we would get ln of f of 1 over f of 1. And that's going to be over x, which is 0 in this case. So that would just be ln of 1 over 0. ln of 1 is just 0, so that's 0 over 0. And that gives us permission to use L'Hopital's rule. So I'm just going to rewrite this to make it look better. So the x is on the bottom, and then I have ln of f of 1 plus x over f of 1. Okay, so the numerator is 0, the denominator is 0. We can use L'Hopital's rule. So I'm going to take the derivative of the top. So the derivative of f of 1 plus, ln of f of 1 plus x over f of 1 is 1 over the inside times the derivative of the inside. Okay, so the derivative, well, 1 over f of 1, that's a constant. And then we can pull that out and take the derivative of f of 1 plus x. Chain rule says to take the derivative of 1 plus x, but that's just 1. So we don't have to worry about that. And that's going to be all over 1, since the derivative of x is 1. Because I'm looking at 1 over f of 1 plus x over f of 1, this f of 1 is going to come at the top. And it's actually even, okay, let's take that back. Technically, that is true, but this cancels with that, f of 1. So we don't have to worry about bringing it to the top. And what I'm left with is e to limit as x approaches 0 of f prime of 1 plus x over f of 1 plus x. I'm going to plug in x equals 0, and I'm going to get f prime of 1 over f of 1. And if we go back to the top, we said f of 1 is 3, f prime of 1 is 6. So that would just be e to the 6 over 3. And our final limit is e squared. Okay, the next one we're going to be looking at an interesting limit. We have limit as x approaches 1. The integral of 4 from 4 to f of x of 2t over x minus 1 dt. So this limit looks a little confusing, but what we can do here is, well, the first thing a lot of people will do is just plug in f of 1. And by the way, f of 1 here is going to be 4. So they can say, okay, limit as x approaches 1 for f of 1. That'd be 2t over x minus 1 dt. And this will just be 4 for 2t over x minus 1 dt. So because these are the same, the integral will just be 0. But that is not correct. So we're going to try something else. So let's not do this. Let's instead take the antiderivative of this. Okay, so let's first evaluate the integral and then go from there. So if I were to do that, it would just be t squared over x minus 1, evaluated from 4 to f of x, Okay, plug in f of x first. So that's f of x squared over x minus 1. Minus, plug in 4 for t. We get 16 over x minus 1. So that would just be f of x squared minus 16 over x minus 1. And then we would need a limit as x approaches 1. So in this case, plug in x equals 1, you get f of 1 squared minus 16 over 0. F of 1 we set as 4, so that's 4 squared is 16 minus 16 over 0. So that is 0 over 0. So we can use L'Hopital's rule. So we're going to take the derivative of this top and this bottom. The derivative of the bottom is just 1, so I'm not even going to bother writing that. So for the derivative of f of x squared, I can think of f of x squared as f of x to the second power. And I could do the chain rule by bringing down the exponent, keeping the inside the same, subtracting 1 in the exponent, and then multiplying it by the derivative of the inside. And the derivative of negative 16 is 0. So I don't really care about that. Okay, now I'm going to plug in x equals 1. So I get 2 times f of 1 times f prime of 1. We said f of 1 is 4. So this thing is 4. 2 times 4 is 8. So that's 8 times f prime of 1. Okay, and that is our limit.